Applause for Ben.
Hi. So put your hand up if you were in the last talk on pointers. Okay, good. So some of what I talk about will overlap that. So I'm going to talk mostly about moving objects from one Python process to another Python process, mostly using a library called Pickle, which is built into Python, so you don't need to install anything. So here's the simplest use case, simplest plausible use case I could think of. Is say you've written your little toy game and it's got a high score table. So I'm going to store the high score table here. It's a list with some tuples. There's me, I got 99 points. Sally got 107 points. What I want to be able to do is close my Python process, turn off my computer, go to bed. When I open my computer tomorrow and start the game up again, I would like the high score table to still be there, even though I've turned my computer off. Okay. So we can do this. Got some high scores. I can open a file in binary mode for writing, scores.pkl, and I can say pickle.dump high scores into the file. And then turn everything off. It's going to write a file to disk. For this, it will be 51 bytes. And then tomorrow, when my game starts up again, I can open the same file in read mode, and I can use pickle.load to load it back in. And that's Pickle. So if you just want to use Pickle, that's everything you need to know about how it works. One slide Pickle tutorial. I'm going to dig in to actually what happens when you do that in the rest of the talk, to help you understand how it goes wrong and when you should and shouldn't use this. So where I use this for my real work is I work on a project called Parcel, where we run a lot of, that's our advertising text if you want to read it. We run a lot of code on supercomputers where you might have 1,000 Python processes running user code, and a user has some of their data in an object in one process, and they want to manipulate that data in another process. So we need to move or copy that object from one process to another, and Pickle is the mechanism that we usually use to do that. So this talk is basically the frustrations I have encountered whilst working on this code base. So at least 3 people have said to me, when I said I'm giving a talk on Pickle, they've said, don't use Pickle. First, no qualifications, just straight out their mouth, don't use Pickle. That's basically the first thing they've said to me. So I've got a couple of slides on don't use Pickle. So if you're a web person, you will have encountered JSON, the JavaScript object notation. There's plenty of support for that. I assume Django does it well because it seems to do everything, if you were here yesterday. There's also a library called Pydantic. There's also a very simple JSON library built in called JSON, and you basically do the same thing. You open a file and you dump your objects. And what comes out instead of a 51-byte pickle is some JSON code. So why would you use that instead of Pickle? Well, if you're doing any web stuff, you're going to be very familiar with JSON. If you're doing stuff with other programming languages, there's a library. You could write this example or the corresponding code to read. Every programming language in the universe supports this data format. Or you might go really complicated and store your data in a database. I think Django also helps you do this, I guess. I use a library called SQL Alchemy. And there you would have to design a schema for your data, maybe have a scores table, and then use something like SQL Alchemy to help convert your Python objects into something that lives in the SQL database. And where's that good? Well, if you're going to do something that isn't just load all my data in, if my game is really popular and networked and I have 1 billion players and 1 billion high scores, I don't want to load this giant object into memory. I might want to make a query against it like, give me the people who've scored more than 85. And a database engine is substantially better at doing that than loading it into a list in memory. Okay, so if you're doing queries, partial updates, if I just want to update one score, something like that, if I want access over the network, databases and that sort of stuff are also an alternative to Pickle. So that addresses everyone who says don't use Pickle. Think about things like that. There are plenty of other ways to store data as well. So I'm going to talk about what actually gets written. When we ran this code, it made a 51-byte Pickle file. And I just said the only thing you can do with it is load it. But it's actually a bytecode computer program for a little mini virtual machine called the Pickle virtual machine. And you can disassemble that using a built-in thing called Pickle tools. And here's the program. So when we serialize this, what we get is a sort of assembly language program. And when you run this program in the virtual machine, it's going to build this object. Okay, so loading a Pickle means run this program inside my other process. Okay, so I'm not expecting you to become mad assembly language programmers in this weird language, but I'll just go through. We're going to make an empty list. There's the list. We're going to have a string, Sally, and number 107, turn them into a tuple. That's this tuple. We'll do the same for Ben and the number 99, because that's there. Same with Philip, and then we're going to say stick all of that lot into the list. Okay, and when we run that little program, what we end up with is this object here. So that's what it means to unpickle. So when you say pickle.dump, it writes that program for you, and pickle.load runs that program for you. Okay, so that was a pretty simple, simple example. Simple in Python and very simple to pickle as well. I'm going to go through a few different kinds of objects that are a bit more awkward to pickle. So there's one with cycles. Basically, it's a shame you didn't get a bit further in your talk, because this is the same kind of setup. If you have objects with cycles, what are we going to do? I'm going to say I've got a dog, Fido, and an owner, me, and they're cross-linked. Okay, so that right down here. Fido's owner's pet is Fido. And that's an infinite cycle. I can say Fido's owner's pets, owner's pets, owner's pet forever is Fido. So if I come to pickle this by saying, all right, to write out a dog, I'm going to write out the owner first. Well, now I'm going to write out the pet of that owner. Now I'm going to write out the owner of that pet. And now I'm going to write out the pet of that owner. I clearly can't do that, right? It's just going to be this infinite file. I tried to make the simplest version of that is an empty list, and it has one element, which is itself. Okay, so if you imagine trying to print this in your head, what are you going to print? Open square bracket, then the first element, which is an open square bracket, and then the first element, an open square bracket, forever. So to pickle that, we're going to make an empty list. We're going to basically use the equivalent of variables in this assembly language. We're going to say, all right, store that list into variable 0. Now retrieve it back from the variable and append it into the list. So that ends up looking in that weird assembly language exactly like this code fragment. Make an empty list, copy it into itself. Okay, and this is a reference. It's not copying the whole list. It is saying the reference to this list gets put into the list. What else? Okay, functions and classes. Depending on what your head thinks about computer science, you might very strongly think, of course, you should be able to pickle a function or a class definition. You might think, of course, it doesn't make any sense at all. What happens with pickle if I define a function and then dump it into a pickle file, the assembly code you end up with this. You see it's got a module name and a function name and nothing else. It just says, well, we're just going to run this import statement. And that's enough to retrieve the function at the other end. And that only works if you can actually import the function that you pickled, because it's sending it by reference, by name. So that doesn't work if you've got closures. So if you've defined a function inside another function, because you can't import that as a statement like that. It needs you to have whatever library that came from needs to be installed at the far end. So if I'm using some specialized science library on the saving side, I've got to have that science library installed when I unpickle it. They have to be the same version, or at least compatible versions of the library. And if you do it in your main script, well, the module that lives in is called __main __. And that, if you depickle in a different program, is probably also doesn't have that definition. So basically, you can pickle functions from a library in it and not from anywhere else. But you can get all these add-on libraries for pickle. So pickle is extensible. The ones that I use are that I encounter are dill, cloud pickle, and tracebacklib up there. And this is dill's sales text from their GitHub. And they claim, or dill claims to be able to serialize with pickle a lot more stuff, including any function you can define without those restrictions that I just said. So what does that look like? Here's my function. I'm going to use dill.dump now. That just wraps around pickle, but with some additional code that knows how to serialize these extra talks. So it still outputs this little pickle virtual machine program. Here it is. What it looks like is it says we're going to look up this dill.create function, import this, which is a helper function. Then we're going to have a load of data, about 200 bytes, 300 bytes of data, and then we're going to invoke create function with all of this data. And what it actually does is pulls the compiled bytecode out of the, or Python, or at least in CPython, compiles to this internal bytecode. It pulls that data out, the virtual machine code, sticks it in here, and then when you deserialize it, it injects it into your receiving Python process, which is either the neatest pickle hack ever or the most horrific pickle hack ever. It's incredibly sensitive to versions. It works really well when it works, but it's incredibly sensitive to versions. And our users do it a lot, but it makes me cry that this is the way it's done. So I can't recommend it, even though that's our default behavior. So I'll talk a little bit about the sameness of objects. Here's this object. This is the ghost for the title of my talk, the ghost of distant objects. Right? We start with this object graph. We go to a pickle and we deserialize it. And what we've ended up here is it's not that same object, right? I can call ID on that object, and I can call ID on this object, and I can see that they're different objects. Okay, and if that process is still running and I mutate it like this, now there's 4 scores there. Well, over here, I've still only got 3. So they're very clearly different objects, but there's something that's the same about them. This sort of value that they contain is the same. So you would expect if I asked for the first high score, I'd get this. Well, then I would expect to get the same over here. Okay, so the object itself isn't being moved, but the value that lives in the object is what's being copied. And in Python, that's a little bit vague and wishy-washy, but that's essentially what's happening. Oh, I have to run back over here. Okay, so there's a new kind of awkward object, which is objects that aren't values like that. And the 2 examples here are when you open a file, you get this F, which is this weird Python internal type that you've probably never seen the type name of. And that's the thing that we can write data to. If you use concurrency, you might have a lock, for example. That's also a thing that doesn't contain a value. A lock object represents the dynamic state of the execution of your concurrent program rather than a value, right? So it doesn't make sense to pickle it. If you try and pickle it, it will say, I can't do that. That's fine, because you probably wouldn't want to, because it doesn't make sense. except you might use a lock like that in an object which does have a value. So I'm going to give doglib.py, which is a class representation of a dog, a bit more advanced than the dog earlier on. It's got a name, it's got the number of bones it's buried in the ground, and the number of bones it's eaten. Okay? And there's a lock so that we can make sure that if we're updating these, we do it in a thread-safe manner. So two things I can do. I can give the dog a bone. We take the lock and we increase. The dog goes and buries it when you give it a bone. We increase that by 1. There's a lock protecting that. Or the dog can sort of go and do this deferred bone-eating process. We take the lock. It's going to unbury a bone, and eat a bone. Okay? So we've got the lock so that we can do this transactional behavior without anyone seeing the state change. That makes sense to pickle, right? I might want to pickle this kind of dog object to disk. And what would I expect? Well, I'd expect it to remember the name and the bone information. But I can't do that because there's a lock object. So if I try and pickle Fido, I get this thread.lock, this can't pickle thread.lock. Okay. So what we can do is tell Python how to pickle that objects of that class. So what I just said, it makes sense to store those values. It doesn't make sense to store the lock. So what we can do is make an unpickle helper function, and we're going to pass in the name, the number of bones buried, the number of bones eaten, and what that's going to do is make a new dog object and reconstruct the state. And then on the pickle side, in the dog class, I can say, all right, to pickle this dog object, don't do your normal behavior. Instead, what I want you to do is write out instructions to invoke unpickle lockdog on the remote end, just with these 3 parameters. Okay? So it's sort of like a remote procedure call. On the pickling side, I can make like a remote procedure call into the unpickler to execute that unpickling code. So we do it with the lock taken so that this is consistent, but we don't send the lock. And on the unpickling side, this is going to get a new lock as part of the dog constructor. And what that looks like is nothing too crazy. We're going to look up unpickle lock dog. We're going to have Fido 0 bones buried, 1 bone eaten, bake them into a tuple, and invoke that function with these arguments. That's cool, right? So, warning, the pickle module is not secure, only unpickle data you trust. That's it. One of the one of the very valid reasons to not use pickle is this warning. Hopefully, you've seen enough to see that the big thing that I can do if I'm taking a pickle that you are going to unpickle, that means I can run any code I want in your process. Okay? So I can run eval and paste in arbitrary Python code. When you unpickle this untrusted pickle I've given you, you're running my code now. I own your process at least. So that's the background behind that. And, so I'll come to the end now. My final slide, let's just do a summary. Pickle turns objects into byte streams. You can send those byte streams over the network. You can save them to disk. Whatever, you could put them in a QR code if you wanted to do something really weird. There's other ways you can do it. The 2 big ones I presented are JSON and SQL. Lots of other ideas. There's this idea of the same object that maybe even leads on to notions of I want to have a network proxy for another object so that you get RPCs and all kinds of stuff there around the notion of what is the same object. It's really targeted, as you've probably seen from that machine code stuff, it's very targeted at Python. Right? So to deserialize that stuff in any other language would be really hard because it's got to be able to execute arbitrary Python code. It's very extensible. There's libraries of extensions you can get like DIL. You can extend it yourself. don't run random people's programs in your unpickler though. Okay, that's the end.
Okay, thank you, Ben.
12 seconds over.
Yeah, does anyone have a question? Some live questions? Yeah.
Yeah.
I wonder why Pickle uses like separate VM. Why not just bytecode? Because it's unsafe anyway.
Yeah, it's interesting. I've got no idea. It's probably lighter weight, but
I have like I guess maybe it's more compatible like between like architectures or something. I'm not sure
maybe.
about the bytecode, but
yeah, I'm not really sure of why they designed it that way. It's quite a warty old data structure. When you go and look at the documentation, then they're like, oh yeah, in version 3.1 we added this thing on, and then in 3.2 we added this other stuff on. So if you that extension mechanism looks quite ridiculous if you read it without the historical context.
Okay, any more questions? We have time for a few more.
No?
No?
Cool.
Okay, so let's thank Ben once more. Thank you.
Thanks.